Hello, my name is Atharva. I am here to explain how to develop a Verilog program to design a combination circuit. The combination circuit which we are going to design is 8 is to 3 encoder. Understanding what is 8 is to 3 encoder is. The purpose of this encoder is to convert the 8 input signal into 3-bit binary output, which simplifies the data by reducing the number of lines. The binary output which we are able to get out of it represents the binary code of the active input line's position. A single active input, the only one input should be active at a time for correct encoding. The application, common in digital circuits for data compression and signal routing. The efficiency of the encoder is to reduce the complexity of multiple line signals into compact binary form. This is the representation of 8 is to 3 encoder, which is represented by the 8 input signals on the left hand side, while the 3 output signals on right hand side. Truth table representation of the 8 is to 3 encoder is shown here. Throughout the truth table, we are able to get 3 Boolean equations. Through the Boolean equations, we are able to design the circuit diagram of 8 is to 3 encoder, which is the representation of 3 OR gates. This is the Verilog module program used to implement the design of 8 is to 3 encoder. As you can see, the first line contains the name of the module encoder 8 is to 3, and in the brackets represented by the D in ABC, which are the variables for representing the input and output signals. In the second line, we are able to see the representation of the input signal, which is 7 is to 0, represented by the variable D in, as it contains 8 input signals, so 7 is to 0 in vector form. The output represented by the variables ABC, as we need 3 output signals. Below we can see the use of case statement syntax to write down the program to implement a 8 is to 3 encoder. As you can see, the first line contains the input in which we have seen in the truth table, that is 1 0 0 0 0 0 0, represented by the output A0 B0 C0. Throughout using the truth table, we should implement the other statements for getting the accurate 8 is to 3 encoder. After writing down all the statements, we need to end the case so as to not run the program into the loop. And at the end, we should end the module so that we won't get any syntax error. The Verilog test bench. The Verilog test bench code or the program is used to test the 8 encoder, whether we are able to get the desired output or not. So the name of the test bench is module encoder test bench, represented by the input signal reg, while the output signal wire. The representation of input signal 7 is to 0, that is in the vector form containing 8 input signals, while 2 is to 0, the representation of 3 output signals. The input signal is represented by the capital letter I as an input variable, while the output signal is represented by the capital letter Y as output variable. We can see the representation of the test bench, in which the input signal is given as function to test the following encoder. Same, we need to end the module so as to not get the syntax error. We need to write the same way test bench for representing other encoders also. This is the RTL schematic diagram of 8 is to 3 encoder. This is the inside representation of 8 is to 3 encoder, which contains multiple signal lines represented by multiplexers. This is the representation of the timing diagram, which we have obtained because of the test bench we have written down. As you can see, the desired output at 001 output signal is 00000010. So on for the other test bench codes also. At the end, the conclusion, in summary, we are able to understand the 8 is to 3 encoder reduces multiple inputs. Uh, getting a desired output in form of 3-bit binary output, making it useful for prioritizing the signals in digital system. It helps in developing the Verilog code and reinforces our understanding of encoding in digital design, helping the streamline complex signal processing tasks in hardware applications. Thank you.